Hello, everyone. Thank you very much for joining the Counterpoint podcast. We're delighted today to have Kumi Thiruchelvam joining us from a company called Quantique. Hello, Kumi.
Hi there. How are you?
Yeah, very well. Just suffering through this lockdown like everyone, working from home. So, if you hear dogs barking and children shouting, I think everyone's in the same boat.
We'll know you're in the Prime Minister's cabinet meeting if we hear it.
Exactly. So we're also joined by Satyajit Sinha from Counterpoint. Hi, Satyajit. How are you doing today?
Hi, Peter. Hi, Kumi.
I accepted it. Nice to see you. I'm here again.
So the subject of today's podcast is securing the Internet of Things. Quantique has a particularly interesting technology to do that. But before we get into it, maybe Kumi can give us a quick introduction, firstly to yourself, because I think you've been around the industry almost as long as I have, and maybe just a kind of a quick overview of Quantique and what you're doing there. But then we'll kind of get into a more general discussion about the problems that need to be solved.
Sure, happy to do that. Yeah. So I joined as co-founder and chief commercial officer back in the summer of 2020. Seems a long time ago. With a view of commercializing and productizing our very unique, innovative technology. Myself, I've been in various cybersecurity businesses in silicon fingerprinting, in biometric authentication, and even built up a business in South Asia related to mobile digital identity, which I guess is where my affinity to cybersecurity started from. Before that, I've been a variety of chip companies, embedded software in smartphones, where we may have come across each other before, Peter, and with a telco service provider background originally, graduating as an electronics engineer. So Quantique, relatively young company, 3 to 4 years old. It was founded by two technical visionaries, Dr. Sharam Masayebi, post-quantum cryptographer, and also Dr. Patrick Camilleri, PhD in microelectronics, with a vision really of making every connected device secure at foundation. So we believe passionately in foundational IoT security, and we're promoting essentially an overall business model that I'll talk to today on this podcast around hardware-enabled security as a service. So very much about scaling fundamental hardware security, leveraging identity derivation using a phenomenon known as quantum tunneling. And we'll get into that, as you say, later. And yeah, I'm very passionate about seeing some of the major moves now in industry related to security at IoT edge nodes.
Great. Thanks, Kumi. Maybe just sort of following off from that. One of my favorite Twitter participants, if I call them that, is the Internet of Shit. It's always good for a laugh. But when you actually kind of look at a lot of the things that they post, the problems that the Internet of Things is throwing up often is related to security. So maybe you could describe in a more kind of general sense what the problem is that IoT type devices create, and how we can get into a bit of a discussion with Satyajit as well about how that problem is addressed in different ways.
Sure. So I think it's generally the move to cloud computing and the need for businesses to move on-premise compute to cloud computing is adding to what you're describing there about security concerns, and more or less daily there are vulnerabilities being exposed. I think it started about 5 to 10 years ago with connected things in smartphones. And so what did smartphones enable all of us to do around the planet was to execute a digital life, right? And we're having a podcast here that's executing using a digital platform, digital audio platform, right? And so in a way that volume, if you like, of vulnerabilities on username and password fraud has kind of now then moved into the vulnerabilities in the Internet of Things. And I tend to call it identity of things for the very simple reason that I think when we were connecting people, we had something called a subscriber identity module that provided an identification of an individual to authorize to access network resources. And I think what that sadly, I draw the analogy there because I think that's been missed in the deployment of the Internet of Things over the last 10 years or so into various sectors. Various sectors, and I think the consumer, the smart home is probably the greatest risk out there today because generally people are connecting things to the internet for convenience, for on the back of what very powerful brands in China or the US are providing us in terms of platforms to execute our digital lives, providing business information and analytics. And therefore, the exposure of devices being connected to the internet is not really being understood either by the consumer or indeed more often now the enterprise. And that's where we as Crypto Quantique are focused at is the vulnerabilities, threat models that exist, connecting objects for the correct business reasons, for the correct digital transformation reasons within enterprises and businesses. And essentially, we're creating these insecure devices at the edge of our corporate networks that allow various people, rogue actors, or in the future, we believe quantum based computer attacks to then come in through backdoors and other forms of attacks to compromise systems. And we've already seen this in industry with stories from around the world of grids being locked down, of modems in networks in the US being compromised and cloned and counterfeited. What amazes me, and it continues to amaze me, is how blasé people are to this threat. And if we can learn anything from this global pandemic that we find ourselves in now, I think it's not to be blasé about threats and then reactive. So our mission about being foundational and secure by design is really very much that. It's about accepting the fact that we've got devices being rolled out for 5 to 10 years, and therefore, as you guys were talking about earlier, future proofing the deployment of IoT needs to start, we think, with hardware security.
Great, thanks. Satyajit, could I bring you in? You've been talking and writing a lot about securing devices from the chip to the cloud. Can you sort of set out the way that you see this and get into the discussion with Kumi here about how you see that shaping up?
Yep. So for IoT, we have seen, the traditional security method of software approach is not going to work. You need to apply all four layers of security from hardware, software, network, and cloud. And what I wanted to understand from Kumi is what is the future of IoT security? How do you see the to secure chip to cloud, where it should begin and where it should end?
Sure. So I think you've highlighted in your description of those four sectors very eloquently the fragmented nature of today's identity of things. In that there are so many industries within the four sectors that you've just described that are driving digital enterprise, digital transformation for industrial IoT. So we as a company do believe it starts with the hardware level, because if you think about the most secure, robust protection that you can have, it's at the hardware level. And in fact, that's directly analogous to the maximum impact we've seen in systems when hardware have been breached. Very good examples recently of Intel's hardware root of trust and the way that they have derived it in the US being compromised in major systems, right? There were major vulnerabilities. If you go back 2 years, you saw the industry run around Spectre and Meltdown and what was happening there in various different systems at the chip level. So if I then fast forward, if you like, or up the value chain to the enterprise and what they're doing, essentially they're having to trust the device procurement ecosystem. They're having to trust their credentials onto cloud systems. Major cloud transformation companies, I think we know who they are. So I tend to think about it more such as cloud to chipset. So whilst chipset companies have, in the last 10 years, and particularly industrial microcontrollers, moving to a position of secure provisioning to cloud, what I've seen to date is essentially chip companies, industrial microcontrollers, saying we are certified or compliant to, say, AWS IoT as one example. Actually, Peter will remember this. It reminds me of the chip world saying I am certified to Windows Phone OS. I am certified to Android. I'm certified to a Symbian software. It reminds me of that. And that's why internally I call about the concept of vertical integration from cloud to chip, not chip to cloud. Because I think the liabilities and the warranties for enterprises will actually be borne by cloud companies first and foremost, not the chip company in a module that has a very convoluted device supply chain. And so I think the future of IoT security in who will really take a lion's share, a market share in the identity of things, from what I've seen to date over the last 2 to 3 years, is from major cloud transformation companies. I don't just hold the tier ones here, but there are a number of tier twos, tier threes. I think you'll see HP, IBM, and others will play in this space as they're also going through a journey from on-prem enterprise compute to providing services in the cloud. And as they start servicing their long tail of enterprises, the 10,000 SMEs in each country, for example, as an average, those are going to need total solutions. They're going to need end-to-end solutions. And I think that's where we're going to see the majority of proactive action for hardware security coming from. We've already seen some initiatives in industry over the last 24 months, and we as a company are absolutely playing in that space.
Uh, yeah, I understand the urgence of hardware level security, and we have seen a growing focus on hardware level security in the industry in the recent years. What you guys are working on the hardware level security?
So thank you. So essentially, we believe in identity of things, as I mentioned earlier, and we need to think about how identity is derived and then subsequently provisioned. So our thesis, and this is what Sharam and Patrick, patented a long time ago, and we're now putting it into practice in a number of internal development chips, is on-chip identity derivation to generate multiple seeds, if you like, that can act as the seed for cryptographic operation in public key infrastructure networks, if you like. And we believe that that's more secure than today's default position, which is either create randomness through a random number generator block of some sort when you need to have memory to securely store those keys that are generated. Or what I've seen also in the last 5 to 10 years is industrial microcontroller companies coming in, and where the few percent of their portfolio customers require security, they're injecting keys. So our view is that those are fallible, right? Those databases can be seen. I won't bore with you detail, but people are, shipping XML files over emails, having, 1,000 device addresses or device identity, right? Think about cloning and think about counterfeiting opportunities that exist in that scenario. So for us, it's about on-chip derivation, and on-chip derivation therefore relies, in our view, on the most purest source of entropy. For us, that's mixed signal IP. It's an analog IP block that is leveraging the phenomenon of gate tunneling, essentially, in a piece of silicon, leveraging quantum tunneling in order to be able to present a very large key space on a piece of silicon that can, through appropriate firmware operation, generate multiple keys, which I'd like to scale as a service. So that's how we view hardware security, through quantum safe technologies, because our generation technology, our key generation technology, is very much a physical analog as opposed to a mathematical approach. And so Peter was talking about the future. I did allude to the fact that with quantum supremacy and various other companies now investing billions in quantum computing, including state actors, that I do think that there is a real risk of today's public key infrastructure using mathematical encryption models with keys that are fallible. We have significant risk in the protection of our internet in the future.
Just diving a little bit into quantum tunneling, because I'm very intrigued by this. So, as I understand it, and please correct me because I'm probably wrong, what you're essentially doing is using the property of silicon chips that leak electrons through gates, presumably in a unique way per each chip. And am I right in thinking that
You
each
are.
chip essentially has its own sort of fingerprint in the way that it leaks electrons, and that's the basis of the cryptography that you use?
Well, that's a seed. That is the basis of the technology, and we've filed patents accordingly. So I won't go into too much detail on how exactly we do that. But essentially, you're right that there is at a certain geographic node, let's say geo node, sub 70 nanometers, which is why I'm interested in industrial IoT, this phenomenon of gate leakage increases. So as the semiconductor industry has actually been trying to remove this phenomenon because it impacts yield. And you may or may not have heard me say that it's very clear that the entire semiconductor industry essentially puts profit before security. And I'm not, I mean, that's no secret, right? You just have to read the shareholder reports of the public semiconductor companies around the world to know that profit really is something that's number one, not security,
Mm-hmm.
right? And I think, as I alluded to earlier, the semiconductor industry generally will take a view, particularly industrial microcontroller companies that are operating at $1 ASP, will take the view that if and when a customer requires it, I will put some kind of security in there. Otherwise, it doesn't help me. It doesn't help me sell. It impacts my ASP and my bottom line. So I'm not going to go there, right? And that's why I tend to talk, Satyajit, more around cloud to chipset, not the other way around. I think that's the direction of travel. Coming back to what Peter was saying, yes, we're leveraging this phenomenon, this gate leakage, current leakage at sub 70 nanometers and below phenomenon, and it's really quantum physics led science actually to create a key space where there's a quantum driven array. So what we're able to do is to, with an analog front end and a quantum driven array, actually read not one but many seeds that can act as root keys. And we've proved it internally to ourselves, not in one, but three development chips with our foundry partner.
And so is your business model essentially kind of licensing the IP, or is it, actually in the production of chips?
Good question. So making chips is incredibly cash rich, as I think companies in the UK and Europe have found out, as the current funding structure of ST Micro indicates, and what I experienced myself at Broadcom. And so we are not making chips as a business, although we have done development chips, which allows us to go through a process of design, test, validation that we would expect a silicon manufacturer to do. Or indeed, what we're seeing in industrial IoT, we're seeing major OEMs actually delving into chip design themselves. And so our business model essentially is absolutely to protect the unique innovation that we have on the chip side. We filed a number of patents actually related to this and successfully defended some of these patents in the chip IP world. And we'll protect those patents through contracts. And we do want to proliferate that IP. Whether that presents a monetized opportunity or not remains to be seen. We're certainly talking to some partners who are willing to pay for the IP, but that's not the big game for the company. As I said earlier, it's about reducing friction upstream of the device supply chain to enterprises and to cloud transformation companies that are clearly taking the profits of IoT out right now in terms of global market share. That's what I want to position the company towards is that area. So so yeah, I mean, the business model itself, when I mentioned as a service, I think there's a huge opportunity for companies like us and others to provide hardware security as a service.
Thank you, Kumi. It would be great if you can share a case study or scenario of quantum cryptography and which companies would be benefit from this.
So I think anybody, as I alluded to earlier, worried about deploying systems for 5 to 10 years and then thinking about any kickback in terms of liabilities or warranties in terms of breach. I mean, it could be quite terminal for certain companies, right? In the IoT device procurement side, or indeed enterprises, or indeed even larger cloud transformation companies. So we do think that those industrial IoT companies, some of the larger industrials in the world that are certainly spending billions digitally transforming, are of interest for this technology and have indicated that in our previous journey with various accelerators that we've been part of, including in France, including in the UK. And so it's difficult for me to talk about a specific case study because of the fragmented nature of the industrial IoT, but there are certainly cases of smart factory, smart manufacturing, anything related to smart cities where public sector is quite involved, critical national infrastructure. I do think that energy is going to be a huge area of potential attacks from rogue states and actors. I think that's why it's called critical national infrastructure, and it's being borne out in the times that we live in right now in terms of the need to protect such critical national infrastructure. And indeed, one of our partners in France, who are running a cybersecurity accelerator for the French accelerator, created a smart city architecture using our technology actually as a proof of concept. And they're successfully promoting that in France at the moment. And the company is one of Europe's largest. It's Thales Gemalto.
Well, maybe one last question from me, and then we can wrap this up. So, you know, I think it's sort of fascinating, developments going on. But where do you see the next, say, year to 3 years? Obviously you've got a fascinating technology which is finding good application, but Crypto Quantique is still, a relatively small player, and certainly our observation of the IoT space is that that there's a sort of a mix of hyperscale players as well as quite a number of smaller players. There's a lot of system integration going on, which brings together multiple different elements from different suppliers, different different hardware suppliers, different software suppliers, which must in and of itself kind of create vulnerabilities in the final solution that's delivered. How do you see this sort of playing out in terms of the increasing maturity and ultimately the creating, as you were sort of talking about, smart city applications or critical infrastructure applications, which must have security as among the kind of the primary design considerations. We're also kind of looking forward to a situation where, for example, cars become more autonomous. The idea that rogue actors could get control of cars and turn them into 2-ton missiles. Maybe a kind of an extreme scenario, but not beyond the realm of possibility. So, maybe you could sort of talk us through where you see the next, as I say, kind of 1 to 3 years, maybe a little bit beyond, and the role that Crypto Quantique can play in that.
Yeah, sure, Peter. So I think let's pick up on that autonomous vehicle analogy that you drew. I think that's a great. I didn't mention that to Satyajit earlier, but I think that's a great vertical for us to consider with some of our scaling partners actually, because if you think about an autonomous vehicle and you think about the need for perhaps an identity associated with the device to one individual, perhaps a different key associated with a different individual, you're minimizing risk. At the end of the day, security is a layered onion. You're not never going to prevent someone who's very dedicated with enough resources with a potential quantum computer in the future, which may intersect very nicely to when cities and countries around the world do deploy autonomous vehicles, more mainstream than the little installations that we see today. So I think that's a great application where the single piece of silicon can actually be bound with different identities on chip derived and then associated with different people or different your manufacturer or a government or a different fleet owner. So I think there's a very good example where identity as a service, and that's kind of what we promoted, a few years ago on digital identity, I explained, but really bringing identity as a service and provided through keys, cryptographic keys, highly strong cryptographic keys will make sense. So to your point about what we'll be doing in the next year or so, we are developing some of those use cases internally, some of those internal demonstrators. We'll do it individually as Crypto Quantique as well as with partners. And I think for the next 12 months or so, that's kind of where we are, to try and promote the need for this level of quantum safe security at the edge node. And I think that's where we'll appeal to. Our audience are already, our target audience are some of the larger companies in the world in this space. From an industry perspective, where I see it going, Peter, to answer maybe your question with an industry viewpoint, I do think you're going to see a lot more attacks being made visible and exposed because of brand liability, brand reputation, warranties. And I do think that you're going to see a lot more being tracked to the hardware root of trust, as I gave the example before. Um, and that will hopefully increase the need for people to consider technologies such as ours as foundational. And at the end of the day, that's what I said is our vision, to bring foundational IoT security to the world using quantum safe technology.
Excellent. Thanks for that, Kumi. And that pretty much brings us to the end of the podcast. So my thanks to you, Kumi, for joining us. Really appreciate your time today. And please look out for the next episode from Counterpoint on your favorite podcasting platform.
Thank you very much, Peter, for the time today. And stay in touch and stay safe.
Thanks, Kumi. Yep, you stay safe, and same to everyone out there. All the best now.
All the best.
Thanks, everyone.